It looks like there's still a few people coming in, in fact a steady stream of people coming in. If there is some space in your row, if you could please defrag a bit, it would make life a lot easier. Squeeze up. Well, ladies and gentlemen, it's great to see a completely packed house here for our last session after lunch here at PyCon 2014 in Montreal. It's quite clear that our next speaker needs no introduction. No, everybody please welcome Python's favorite mad scientist, Dave Beazley.
All right. All right, thank you very much. This is my attempt to come up with the most boring talk title at the PyCon. That was actually one of the reviews in the submission. I was like, is that a terrible title? So what this talk is about is kind of a weird topic. In 2005, I was actually hired to go look at 1.5 terabytes of source code in a secret vault. We'll talk about how you get that much source code in a second. And then 6 years later, I ended up testifying about concurrency and event loops in US District Court. And you're thinking, oh, good God, what was that about? It was not to Judge Wapner, by the way. And so what this talk is about is actually discovering with Python, basically bringing Python into a legal battle. I think in this picture, the chair is Python. Okay, so like that's what this is about. And just to kind of set this up, a little disclaimer: everything in this talk is true, but all the names and details have been changed because of non-disclosure. I'd have to kill you, and it would take a long time in this room. And so basically, the gist of it is, I know nothing, and you're going to learn nothing. So just keep that in mind. Now, to set this up. Got to meet Alice. Got to need Alice and Bob. Meet Alice. Meet Bob. Are we talking about cryptography? I don't know. Okay, so yeah, Alice and Bob. Bob, for whatever reason, wants to send Alice a message that she will understand. And to do this, he's going to employ an attorney. Bob's attorney, Van there. And the attorney is going to nuke Alex with a patent infringement lawsuit, along with an evil laugh. I don't know what happened between the two of them to cause this, but patent infringement lawsuit. Alice, being fortunate, has somehow managed to find Lawrence Lessig to defend her, who is going to crush Van in this battle here. But basically what this talk is about is essentially patents in some sense. I mean, these are things that you hear about a lot in the news, patent infringement and software patents. They're bullshit and all this stuff. I'm not going to really talk so much about that, except to say that if you ever get into a patent litigation, it will turn your world upside down for reasons I'll get into in a second. And it's also something that is kind of the background of this talk. You say, well, okay, why did Dave sit in a vault with 1.5 terabytes of source code? It was basically in the context of a patent litigation. And where it came up is sort of in this timeline of what happens in a patent lawsuit. What happens in these lawsuits is that the suit will get filed, and then it kind of goes quiet for a while. I mean, like if you kind of follow the news, it's like, oh, some company sues this other one, and it sort of goes quiet. The case essentially goes into a phase known as fact discovery, which might last a year, maybe even more, but it goes on for a while. And essentially what's going on in that fact discovery phase is the lawyers and the teams are trying to figure out just what in the world is going on. Essentially what you have is like the plaintiff in a case is saying, well, there's obvious patent infringement, right? An earthworm versus a snake, right? You know what that's about. You have the defendant essentially saying, well, no, the things are obviously different, right? There is no infringement. So you have these two sides. And what is happening in this sort of fact discovery is that the two sides essentially have to take a data from the case, which might be things like specifications and drawings and documents and software and so forth, and sort of figure out what the quote facts are in this legal case. And it's not usually a really clear-cut thing many times, right? I mean, it's not an obvious thing where, well, it's obviously different, or it's obviously the same. So to do this, usually what happens is a fact expert or an expert witness or somebody like that is called in to look at the facts. And in the case of something involving software, it could be somebody in this room, myself in this case. I mean, typically what lawyers are looking for is some kind of technical expert that is unbiased, meaning not employed by either of the parties or have a relationship with them. It would be somebody that would hopefully know somebody. So they typically tend to target like university professors, people like that, that know things. And essentially they're gonna look at the facts in the case. And what you're gonna have is kind of a team that looks something like this. Maybe Bob's attorney. You have a bunch of coworkers, like legal. These are usually like the people at the law firm who haven't made partner yet. That are like their jobs on the line. Fact expert. In reality, it's actually probably more like this. Bob's attorney with coworkers. The fact expert looks like that. In my case, that's me. That's actually what it looks like to bike in the Chicago winter, by the way. I don't know whether people saw the first talk in this session, but they were talking about biking in Montreal, so I would assume it's kind of similar. So that's kind of the team. And if this happens to you, it's actually a really fascinating experience. Like if you get the call, so to speak, saying, hey, why don't you come in and look at some source code for a patent infringement suit, you're essentially going to be dropped into just a huge firestorm of hell, actually. I mean, because what's going to happen is they're going to drop you into this case with no technical guidance, really. And the reason the reason they can't give any guidance is that's because why they called you, actually. They don't know what's going on. So some of the things that are going to happen is you're going to end up getting into this like really quick learning phase where it's like, well, you have to learn what the invention is. Like, what is this patent? Is it BS? Like, what is it about? To do that, you're going to get all sorts of really fun reading assignments. Like, you'll have to read the patent itself, which might look something like this, where it's like, the system of claim 5 or 6, wherein the display and input means comprises display means and input. Like, you read that, and like, it's like your head just head explodes. It's from the movie Scanners, which is, I don't know, I think a great Canadian work of art, actually. Okay, so you have you have that. In the case of this thing, the patent actually had 600 pages of C code attached to it as a PDF, printed in 1989 on like a dot matrix printer, and you get these fun jobs where it's like, okay, you have this. What do you do with this code? I ended up having to basically compile the code from hand. I mean, this is something like if you're going in as an expert, it's like, is this patent, like, is it BS? Like, does it even work? Could you explain this code to other people? So one of the very first things that happens is you have to figure out this invention. In the case of this thing, I actually printed out all of the code and sat down with a highlighter over the weekend and highlighted all function definitions and all function calls. It was only available in paper, basically, right? It's like you print it out, you highlight all function calls, you highlight all function definitions, and so forth. And then I ended up using Python to manually link it. Essentially, you would enter it into just Python data structures from paper copy, and then you would just crank it through Python to do like a manual link. And what's going on here is I'm actually trying to figure out whether that code is actually complete. Does it have code? Does it have holes in it? Are there like missing chunks on it? Chunks in the code? That kind of thing. I'm not going to explain that Python code in great detail, except to say that if you're not using list comprehensions and set comprehensions and the collections module, you are missing out on an awesome secret weapon for getting all sorts of problems solved. Okay, so you sit down for a weekend. You link this code, you would say, well, why would you do that? One of the things that will happen in this legal case is that at some point, if it continues far enough, you're going to be asked about that code, maybe like under oath or something like that. And if you don't know how it works, you're going to look really freaking bad, right? Okay, so you will die basically later if you don't understand the code. So part of what happens is you have to understand your own side's code. So that's kind of interesting. Sort of horrible in a way. I might be the only person who's had to link a 600-page C program by hand on paper and a Python script. So you do that, but then it actually gets even more interesting in these cases. You actually have to deal with the other side. So you have Alice here. What is going to happen, on that side is that you're essentially dealing with like a whole different organization. You're dealing with some company. They're very hostile to you. So you have Alice's group of sort of ninja rockstar coders, that have been doing things. Because you're filing probably since you're filing a lawsuit, you would actually probably not be suing somebody with no money. So it's probably actually not a bunch of ninja rockstar coders, actually. Instead, probably what Alice has is a bunch of engineers, and they're probably SEI, CMMI level 4 certified with like an ISO 9000 certification. Okay, so this is the other side, and something like this is typically not like a startup company. Okay, it's something else, and what they are going to do is essentially kill you with documents. Now it's insane. So it's like in this case, you show up, the lawyers actually took me to a room and they said, hey, yeah, we got some printouts. Can you take a look at the printouts? And just to put like a number on it, ream of paper is 500 pages. A box of paper is 5,000 pages. They had 100 boxes of printed paper, 500,000 pages, actually literally printed out in a room, stacked up. They didn't know what it was. 300,000 pages of it were TPS reports, software change notices, things like that, that they don't know what to do with. Some of the other stuff that you find in there, quote, source code. A lot of people don't know anything in these legal cases. Like, oh yeah, let's just print out the object files. That'll really mess with them, right? Okay, so print out source code. You might get box of emails. Like here's an email from Guido where he says, hey, if I were to design a new language, I'd probably use braces, right? And you can take that to the lawyers and say, oh, I found this smoking gun in the email about something. Okay, so you find that. You'll get things like alleged prior art from all over the place, like schematics. You might get software where you don't even know what in the world it is from like 1983, or assembly code. Like I don't know. Does anybody actually recognize that? And I think that's PL86. I don't know, something like this. You get a whole bunch of unrecognized stuff. The legal team might actually be deposing people at the time, so you might get like a deposition of some crazy gray-bearded guy, right? He'll kind of bring out some stuff saying, well, yeah, I thought of this in my basement over the winter holiday or something like that. So you'll get that, and then the really fun part is you're going to get all their software too. This is in some way kind of awesome because when you get into a legal case, they can go to the other side and they can ask for anything. They can say, hey, why don't you just give us the whole code base, hand it over, and it's all proprietary software. In the case of this. They had asked for the software, and it was actually sitting over in a vault on the west side of Chicago. Just to put some perspective on this, so imagine that this is the Chicago here. Essentially, it's my ode to my kids here. You have sort of this vault in kind of a secret location. That is actually a picture of the real vault, by the way. Sort of nondescript building, sort of nestled by the train tracks. And coincidentally, right next to the rock band rehearsal space that I was, I'm actually in that picture, by the way. There's a part of the rock band there. So it was kind of nestled in this very sketchy part of town. The protocol for the vault is you can't have any computers, no phone, no electronics, no storage, and you can bring a pen and paper book. That's pretty much it. They had a PC locked in a cage, along with a printer and a logbook. So that was what was in there. As far as what we found there, it was just a large collection of hard drives, basically maybe 1.5 terabytes of hard drives. And as far as what it was there, it looked like they took maybe a gigantic box of compact discs, and they just copied it on there. in no order whatsoever. I'll say a little bit more about what it is in a second, but just imagine like going through your closet and you're saying, I'm going to find every compact disc that I see in the whole room, and I'm just going to send it over to the other side. And they're going to put it on this machine. So no organization at all. And just to put a little perspective on how horrible this is in a way, they essentially produced like the software archive for pretty much everything related to this thing. So you kind of have the invention, and the things that they were producing were things like, you had like embedded microcontrollers, you had keypads, display modules, 7-segment displays, you had a PC, they had made a custom PCI board with its own custom operating system, custom software for that. System actually involved a second PC. So you have like all these different components. You actually had all the software for all of these things. Like, so if you wanted to know what the firmware was in the display, like the LCD display module, you had that. Yeah, so they kind of gave you the whole works. It was actually more of a distributed system, in fact. So there's like a custom router, multiple copies of devices. The software for this is what I would describe as all stack, not just full stack, but like all stack. So, so you have like essentially about 1 million lines of code involving C++, C assembly, Java, Visual Basic, it's sort of things like they had their own distributed object system, DCOM, Corba, the whole works there. And then on top of that, the time frame of this thing was basically over 15 years. So it turns out, how do you get at 1.5 terabytes? You basically hand off about 800 snapshots of that system over like a 15-year period with all sorts of multiple hardware revisions, configurations, different operating systems, OS2, Windows NT, and so forth. And then on top of that, they had like custom sort of skins on this software, customized for big corporate clients. So it was like there's like a big core of the system, and there's like all these custom skins on it, all sorts of hundreds of interlocking versions, and so forth. And so, so what my job is basically to tell the lawyers, like, well, what is this thing? And the provided tools were Windows XP, awesome. The Windows command prompt, awesome. The search MUT, all right, so, yeah, awesome. I don't know whether, people remember the Windows XP search MUT, but yeah, pretty awesome. You could use Notepad, well, because that came with Windows. And then, because they're feeling generous, they've had Visual Studio on there. Okay, so they had all these tools on there. You could print anything that you wanted, it turns out, in the vault, but it had to be logged, and it was copied and given to the other side. Nothing really happens in like secret in a lot of these lawsuits. Like if you're going to print something out because you think it's interesting, the other side is going to get it too. Okay, so you could do that, but the other side would know what you were doing. And then there was some other constraints as well. There was actually no working hardware setup. Couldn't run the code. You actually couldn't build the code either because of missing libraries. No tech support. Like you can't just call up the other side saying, "Hey, I'm working for the guys who are suing you, and I'm kind of confused about this code, and can you tell me about it?" So there's that, and then very fragmentary documentation. So you look at this and you're saying, "Oh God, this is horrible." So here's the interesting thing. It turns out that in the vault, I go over there, I fire up the command prompt, and I type Python, and it comes up. I'm like, how did it come up? Like no. It's like, this is odd, right? This is odd. I mean, if you've ever used Python on Windows, does it get installed in the path? No, right? It's in the path. Like, who put it there and in the path? The only guess on this is that it was probably used by IBM as part of an OEM tool. I was actually talking to Brian Curtin about this at one point because he does some stuff with the Python Windows. He's like, "Oh yeah, we got occasional like virus reports from users saying, 'Hey, what's this Python thing on my machine? I just bought it, and it was used by the vendor.'" So it turns out it was there for reasons unknown, and of course that sort of changed the whole picture, right? I mean, if you've ever had this thought like, "Oh, Python would be really awesome desert island language," this is like the perfect chance to like try that theory out, right? It's like batteries included. By good fortune, I actually wrote the Python book, right? So I was allowed to bring books into the vault. And I'm like, okay, I'll be back. I'm gonna go get my book. And kind of the strategy on this is I'm gonna go in there and I'm gonna build basically software entirely from scratch in the vault. to do this. And so I'm going to talk about that. Before I get into that, I do want to just raise one question of like, well, what are the objectives of this exercise exactly? Like, I mean, this is a very unusual project where like the lawyers are just saying, hey, go look at the code, and it's like, what do you mean look at? Like, what is that? So if I had to describe the objectives, they're kind of this. One of them was just sort of this what question, like what did they give us? Because nobody actually knows. They know that there's a bunch of hard drives in there, but like what is it? The other thing is just how does it actually work? We'll get to that. And then the third one is the more weird one, is like, because this is a patent case, ultimately you're gonna have to answer where in that code does the patent exist? And that's the weirder one. So, so some of the horror on this, essentially the first part of it is you're gonna have to reverse engineer the whole build environment of whatever this is. Like finding like, well, what are the components? How do they get built? Are they complete? Like what are they? Are they EXEs? Are they DLLs? Are they plugins? You might have to do something like just pick like a directory of code and you see if you can pull it apart. You might look at things like make files, you know, saying, oh, okay, well, here's sources, here's libraries. This is a lot of like just pencil paper, like grunt work where you're just like, oh, God, it's horrible. It's like the last talk, assembling, I actually, don't ask how, I stole this picture from Titus Brown's last talk in the last section here. It's copyright infringement, right? So, no, it's like a jigsaw puzzle, where it's like it's like, okay, here are all the pieces, go put it together. So some of the ways that you do this is, well, the first thing should be obvious, is you have to re-implement Unix. Okay, so that's the first step. So a lot of it, it gives it the search mud. No, I mean, okay, so you have to do some basic tooling to do this. It turns out to be like pretty easy to do a lot of that. I mean, one of the things that you can do is use the Python, like you can just implement like basic Unix commands using like simple Python statements, like basic navigation stuff. This is a six-line program that will do diff between two files. Python has difflib, like you don't need to, you can do diffing. You kind of build up like a little collection of tools, and then you might just use the Python interactive shell to just do your navigation, because the Windows command shell kind of sucks, it's like you don't want to use that. So actually in one sense what you're doing here is you're kind of building your own IPython from scratch. I mean, it's a very stripped down one, but you're literally just sitting over there with the book saying, well, I'm going to reinvent everything I need as I need it in the vault. So just sort of sitting in there, you can do diffs and finds and so forth. But then what you start to do is you start to layer on this thing. You say, okay, well I've got Unix, but now I'm going to start doing some workflow kinds of things, where you might do things like, okay, you might just start with a Python function. Well, here's a function that will produce every single directory name and file name on the whole machine. I tested this out with like every Python version that exists, just as a sample. You might say, okay, well, like if I wanted to find all files in all versions of Python, I would just fire this at it, and it would just start spitting out files. And then that would become, maybe a component in your system, and then you would start building things on top of it, where you would say, well, what did they give us exactly? Like, what are all the file types of everything on all those 1.5 terabytes of disk? You'd say, do something like this, saying, oh, I'm going to make a histogram of all file types, and just kind of see what's there, like how many Python files are there, how many C files are there. You might actually look for things that are really interesting, like unusual file formats. Actually, some of the more interesting things would be things like PDF files and doc files for reasons that we'll get into later, but you kind of inspect what's there. Maybe that would become another component. Maybe you would write some code to find things. You're saying, oh, okay, I want to find all Python files, or I want to do a search. And again, you're trying to uncover things on this huge collection of hard drive images or CD images. So you do things like that. You might write little utility things where, I want to create a manifest of all versions of code provided to us. It's just my excuse to put a regular expression in the talk there. So you would do things like this, maybe run it and identify like all versions of Python and so forth. So you kind of build up tools where you would say things like, okay, identify what's there, and then maybe start writing out manifests of, you're essentially doing a big inventory job of searching through all this data, finding all the versions of things, trying to put it together. The whole time you're sort of consulting with lawyers in a way, saying, I was over there and I found 700 versions of the software, just FYI, or there's 700 versions, it's 1 million lines of C code, that kind of thing. And so you do kind of build up these workflows, and then you can just start piling it up, sort of even higher. I mean, one of the things that happened in this project is that these snapshots were just sort of scattered randomly over all the disks. It was too hard to deal with, so sort of implemented kind of a sort of virtual file system, if you will. It was kind of a layer where you could just enter in like a software version, and it would just take you there. And you didn't have to worry about all the way that it was actually structured. So you kind of layer it up. And some of the stuff that you would do there are just take all these software versions. You would find out things like development timelines, like all the versions, like what range of dates did they go over? Did they overlap? In some sense, you're almost reconstructing things like a GitHub, forking, like history or something like that. You're doing it almost in reverse, actually. You're taking like a bunch of snapshots and trying to recreate history from it. Some other things that you would do are write code where you would say things like, oh, give me every version of this file that has ever existed. Like you could say, like you could pick like a version, and I'm using Python as an example, but you could say, hey, give me every version of thread.c that has ever existed. And it would go through these like 800 snapshots, and then it would produce like some history saying, well, in version 1 and 2 and 1 and 3, it was exactly the same. And then like version 2 all the way up to 2.1.3, there's 7 versions of code where it was exactly the same. Again, what you're trying to do is take all this stuff and decompose it and break it down and do inventories on it. There were also a lot of navigational tooling. Like if you needed to go somewhere, you could write little view functions where you'd say, hey, I want to look at C eval in this version of Python. And then maybe it would launch Visual Studio or something, because I didn't have a whole lot of choice on editors, right? You can't install anything on this machine, so you sort of work with what you've got. So you sort of build up all this stuff. And one comment on this, I'm not actually sure that the other side in this case ever anticipated that we would figure it out. I think that was kind of the expectation. It's like, we're going to take every CD in the closet, in archive. We're just going to send it to them and let them figure it out. I think in reality, we actually almost knew everything about everything. Like we knew all versions of everything that they gave us, and like timelines and all sorts of stuff. And it was all inventoried. I don't think it would have been possible at all without Python. Like, I can't even imagine doing that with Notepad or like the search mut and Notepad. Like, how would I was actually thinking about it recently. I was like, how would I have done that? I guess the only alternative would have been to fire up Visual Studio and then to re-implement Python. It's probably the only. I just don't know how you would do that. So there's that. And then you get into these other horrible things with this code. One of the things that the thing that we just described is just figuring out what is there. We haven't even talked about how it works. It's more like just what is it? So you have this other thing, which is, well, how does this code work? And this includes pretty much everything, like the software architecture, interaction between components, algorithms, the whole thing. As an expert, what you're going to have to do is take that million-line program, and you're going to have to, first of all, explain it to the people that you're working for, and then maybe later on you might have to explain it to potentially like a jury or something like this. So you can't just go in there for 20 minutes and say, yeah, I kind of looked at it. So you really have to pull it apart. And the thing is, reading code is terrible. You don't want to. Do you really want to read a million-line program that you didn't write? That sounds horrible. What you want is design docs and specs and stuff like that. But the thing is, the other side is very hostile. They don't want to help you. They don't want to give you that kind of stuff. So what ends up happening next is you go on what I can best describe as a gigantic fishing expedition for things like interesting documents, like PDF, doc files, RTF, HTML, text files. You do mining of code comments. Actually, one of the things we did a lot, I'll talk about this in the next slide, is you just search all source code for the word C, and you just see what comes up. Because what you're hoping is some developer has written in like a comment, like, oh, this function's really tricky. If you want more details, see this document. Like, what you're looking for is like a loose thread or something. You're looking for something to link off of. You might go looking through all those TPS reports, hoping that somebody dropped a clue. You look through everything. I mean, this is actually, kind of the thing that you would find is you might find a comment that would say something like this, see FS6541 8V20 for the details. You're like, huh, that's interesting. And this is actually one of the cool things about being a fact expert, is you can go to the attorneys and you can pretty much get them to unleash any weapon you want on the other side, right? You can you can go to them and you can say, hey, I think it'd be really cool to have this document FS6541 8V20. And so what happens, the attorneys will draw off the letter and send it off, and then it's kind of silent for a few days, as the other side is like, oh, crap, like, I don't know about that. And then, magically out of the vapor, you'll get some document, Acme widget functional specification version 2.0, and then so tagged proprietary and confidential. And then since this company has their act together, the very first page is the related documents content. And then what you do is you rip that off and you give it to the attorneys and you say, it'd be really cool to get all that stuff too. And you basically will unwind the whole system architecture and all the pieces. Doing things like that, and you search everything. I mean, software change notices, you might actually look for software on something like a display module, like firmware for the display module, because it might make reference to the main application in some way. And you'll just look at it. What you're trying to do is pull on a loose thread, and you're going to pull on it as far as you can pull on it, and just see what their pain point is, before they do that. So that's another thing that happens. One comment on this. I actually think that this is an awesome exercise if you ever get a chance to do this, regardless of what you think about patents. Because if you ever get thrown into the fire saying, hey, you need to understand this million-line program that you didn't write, with no help at all, like no documentation, you're going to learn a ton of stuff reading that code, about everything. Like I'd never seen stuff with CMMI level 4, like this software engineering kind of stuff, which this group was practicing. You get to see that stuff, like all their procedures and their documents, and it's really fascinating to see that. The other thing is you're going to have to teach attorneys about it. Attorneys are not dumb, by the way. Patent attorneys usually have science and engineering degrees. They're often not software engineers, but they're smart guys, smart men and women. They can understand it, but you're going to have to explain it to them. The other side doesn't want you to succeed at this, so it is a little bit hostile. So you will learn a lot. Some of the things that I learned, this is going to get me into serious trouble here, but these are the sucks, rocks lessons of having to look at other people's code that I learned doing this project. C++ and assembly code. Turns out that in assembly code, the code is so minimal that it just does what it's supposed to do. The C++ code needs at least 18 levels of indirection and design patterns. Terrible. Asynchronous and threads, now I'm really in trouble here. Objects, functions, IDEs, make files, pretty much anything actually developed since the 1970s. Sort of. So it's kind of amazing actually, like in these cases, because what they're going to do is trot out things like prior art, and they'll say, hey, yeah, we got this prior art from 1975. Can you go take a look at it? And you look at it, and it's like, this is like 3 pages of code. It's cool. I can understand it, right? And then you compare it to the million-line C++ program, and it's like, oh God, it's like, we've done everything wrong. So of course, I could be wrong about that. And then the other sort of weird thing. Now, this is getting into kind of the weirdest part of this whole thing. In this fact discovery phase, the attorneys are actually playing a very different kind of game with a patent infringement suit. I mean, you're over there looking at the software, and there's these questions like, well, does it infringe or not, and so forth. The attorneys are actually playing a kind of a weird chess game that you will only understand if you understand Bill Clinton's comment about, this famous quote. Depends on what the meaning of the word is. But a lot of people laughed at that and said, well, idiot. It's like they obviously never been in a patent infringement suit. What is going on is the attorneys are basically dealing with the language of the patent. Like you have this horrible claim that made your head explode earlier. They are actually going through that entire claim and fighting about it, what it means. Like, what does this claim mean? And they're going to fight, and they're going to fight in front of a judge over an extended period of time about what this thing means. And just to give you some background, if you love arguments about things like the Oxford comma, this is your battle, right? Okay, like if you love grammar arguments and things like that, this is what they're kind of fighting about, is things like terms and languages. Like they'll take a claim and they'll say central processing unit. What does that mean? And the defendant will say, well, actually it has to be like a model 80486, version 2, exactly at 200 megahertz. And the other side will say, well, it can be any computer at all. And then, the plaintiff will say, well, display could be anything. And the other side, well, it has to be 7-segment display. And they're going to fight over this extensively about what the definitions of these terms are. And the thing is, here's the catch. Whatever they decide the terms are, it actually has to exist in reality. Like, you can't have a definition where you say, oh, yeah, the CPU is this, and then that doesn't exist anywhere. Like, you actually have to be able to point at the patent and say, well, there it is in the patent. And then on top of that, you have to point at the other side, and you have to say, well, there it is over there. So they're fighting over these terms, essentially trying to define things. And I was talking to Van about this the other night. He's like, yeah, this is like a knob where they can turn it up or down to any level of abstraction they want, like down to the atoms of the universe, or all the way up to a planet or something. It's very sort of, malleable in a way. So that's the two sides are fighting about this. But ultimately, what's going to happen in this software fact stuff is you're going to have to be able to point at something specific. Like if the attorneys say, well, this is the definition, they have to be able to go at the code and say, you know what, in this file, foo.c, line 230 to 255, that's where it is. And so this is a problem too, which is, well, how are you going to do that on 800 versions of this million-line program? Do you just pick one at random and say, well, we looked at that one? Or what do you do? The thing that we did in this project is we decided to do all of them at once. And the way that was done was doing something I'm going to call fragment versioning. It's kind of like source code control, but applied to individual code fragments. Essentially what you would do is maybe identify some piece of code that was pertinent to the patent, saying, okay, well, here's this piece of code in question. And you would mark it off as maybe like a code fragment, saying, well, this is the file that it's in, and then it starts with this, this void grok, and it ends with this void blah or whatever. And then what you would do is write a script that would go through all 800 snapshots, collecting that fragment across all versions. And then what it would do is collect all the unique ones that it found, it found 3 versions. It turned out that this was highly effective, by the way. Like, you would find these versions of code, and over the 800 snapshots, you might only find 6 versions of some fragment. And really kind of the thought here is that you're trying to reduce this massive data set to some kind of sane structure where you could say, well, this claim that you have matches this piece of code, and by the way, there's only been 6 versions, and here are the 6 versions. That's the kind of thing that you could present to a judge or something, or whoever, saying, this is what's going on. So as some comments on this, I have the Python thing. My big takeaway on this whole thing is that Python, in some sense, makes an impossible project like that possible. It's like, God, it's like horrible work. Not even being able to bring your headphones into the vault was just like torture. It's like you're in this vault coding, and it's like, using Python, you take this impossible project, you kind of break it down into something that's sane, that you can actually do in a reasonable amount of time. It actually occurs to me that as an expert, this was probably the wrong approach. I probably should have used Notepad so I could charge 4,000 hours of work. But no, Python really broke it down. I would just add the parenthetical comment that even Python 3 makes the impossible possible. And so some final thoughts on this thing. If you ever get a chance to do something like this, you're going to learn a lot. I'm not sure I would want to do it again. There's a lot of things like that where it's like, yeah, it's character building, but you don't want to go through it again. it's sort of interesting. But you might say, well, God, is he near the end? There's this. How did this thing end? It's like I just talked about this legal battle. I don't know. This is the weird thing about some of these legal cases. You might be called into it as an expert. You might work on it for months, and then all of a sudden the thing disappears, and they just pack everything up and goes away. It might have been settled. It might have been thrown out of court. For this case, I do know some details. I know that they lost the case initially. I don't know the exact details of the judgment on that, but it's actually mysterious. Like you're basically only privy to the technical part of the case. You're not privy to things like if they have a settlement or something. You don't know. You don't know how that went usually. So, and even if I did know, I couldn't tell you anyway. So, but it sort of ends abruptly. As kind of a footnote on this, getting near the end here, my end game on this is sort of curious, but I learned a ton of stuff about generator functions doing this exercise, because it was so much data, and I couldn't read it into RAM. It's like, how am I going to do this? I think it ultimately was the background for this really well-known generator tutorial. If you've encountered this online, you wonder, why did Dave do that? It basically came out of the vault, figuratively. Actually, one cool thing about working in the vault is that all code that was written in the vault stayed in the vault. I don't have to maintain it. I don't have to do bug reports. It's like, it's gone. It's like, not my problem, at this point. So it's, stayed there. One little postscript on this too. If you get involved with one of these things, you might actually go all the way to writing an expert report that gets used in actual, the court proceeding. This is something that is actually really interesting. That I'll mention, just speaking as an academic. So, I used to be at the university. I always had this fear or thought that nobody ever read anything that I wrote. There's a number of academics. Does anybody read what you write, Titus, do you think? Take the fifth. Yeah. I mean, there was always this fear, even for my dissertation in grad school, it was like, I don't know. Did my advisor even read my dissertation? I don't know. So here's the thing. If you write an expert report, if you do an expert witness, you're going to have to write a report. I can absolutely 100% guarantee that it will be read. And read at the level of each sentence down to things like commas and stuff. They're gonna take, the other side will take it, and they're gonna unleash 10 legal assistants on it, or attorneys on it. They're gonna read it, and then they're gonna haul you into a deposition, which is usually a bunch of attorneys, a videographer. They'll put a huge this is really cool. Get the biggest video camera that they can find, right, in this little tiny room, and they'll shove it right in your face, intimidate you, and you'll sit in there for 8 hours, and they're going to ask you about the report. It is an awesome experience because here's the thing that's awesome. They have read the report, and they're going to discuss it in depth at every detail with you. And it's going to be a big conversation about your report, and they're going to try to basically destroy you. And so it is a really awesome or horribly bad experience. The way it would be horribly bad is if you went in there and said, well, I kind of looked at the patent for half an hour, and it kind of looked similar. That's how you would die, basically, and something like that. So there's that. Court testimony, I mentioned that I actually ended up going to court talking about concurrency, and you're like, what was that about? It turns out it was related to this claim term definition stuff. There was a huge battle involving concurrency, and the judge was so sick of people battling about it. He's like, okay, everybody come in, you're gonna teach me about it. And I ended up doing a 3-hour PowerPoint presentation on concurrent programming in a courtroom. And then the only thing that was different, it was sort of like this in a way, except that the whole audience was attorneys. And then afterwards, they had their own expert come up and then refute everything that I just said for the previous 3 hours. And then they had this huge battle. It was kind of entertaining there. So that's the end of the talk. We might have a time for, I don't know, a question or something like that. So. Okay, thank you.
Let's go, Larry.
So how long did you spend in the vault, and how long did you spend specifically with your Python automation, developing it?
So most of this took place, I'm going to say probably about 5 months in the vault. It started over the summer and it went for like 5 to 6 months. What was the second part of the question? Oh, on the automation? I think that like the automation part was probably the least. I would say under 100 hours on that. The biggest time sink of all was actually figuring out how the code worked. I mean, because it was like you had this massive, like how would you figure out how a 1,000,000-line C++ program works? I mean, it's a lot of that was like pulling code fragments and building like 3-ring notebooks of like things where you're like, well, this talks to that and this talks to that, and a lot of discussion with like attorneys involving claims, like if you define this like this, you're going to die, and this is the reason why you're going to die, because like this code over here doesn't do that way. So it's a lot of like behind the scenes like consultation of like how things work, how the case is being framed, and so forth. Yeah.
We'll make this the last question.
So had they left you with just the search mud, you might have been dead in the water. How did they feel about you using Python?
I don't think they knew. Well, so it's like all this. They had a question: how did they know that we were using Python? So all that Python code was living on the vault and was, first of all, never printed. So there was no printed record of anything coming up. The case, if it had actually gone to trial, it was fully expected that the code would have been produced. Probably it would have been part of the production. But in this early stage of fact discovery, I don't think they knew. I don't even think the side that I was working on knew what was going on. They just knew that Dave would go over to the vault, like Dave would go to the vault for like a day, and then he would just sort of emerge out of the. The other kind of weird thing about this, by the way, the attorneys asked that I never communicate via email. This is like the ultimate thing. They're like, don't talk to us at all, because like if you're working as an expert, that can be produced later as evidence, and they're just like, well, we don't really know what we want to do with you, so just don't talk to us. So it's kind of like the ultimate work environment. Like you have the client doesn't even want you to talk to them, right? So what you would do is you'd go over to the So you go over to the vault, you kind of work away, and then from their point of view, Dave would magically appear from the vault with this thing like, hey, why don't you ask for document FS861-V2 or something like that? And they were like, oh, that's interesting. And then, so there's a lot of things like that. But
thank you.
Okay.
Ladies and gentlemen, please thank David Beazley.
All right, thanks.
There is an afternoon break downstairs. I think things get started again in half an hour or so. Look at your programs.
All right.
Thank you very much.
Thanks. All right.